Welcome to this QuickControl tutorial video. My name is Noé Gutierrez and I'm the support engineer at QuickControl. In this video, I'll show you how to home to a sensor. Home to a sensor is ideal when a home to a hard stop is not possible. For example, in a continuous rotary application with no hard stop, or if the mechanical assembly is too sensitive for a hard stop. First, I'll show you where a pre-written home to sensor example program exists within QuickControl. Next, I'll build the program from scratch. And finally, I'll show you the program running on a controller with a NEMA 23 motor, which is connected to a belt-driven linear actuator. The home to sensor program exists under the QuickControl examples folder, which can be found by going to File, Open, and under the QuickControl folder, you want to go to the QCI examples folder, then the homing routines folder, and the home to sensor program. So we'll go ahead and open the home to sensor program. And the home to sensor program, you'll see it's a 5-line program, which basically looks for IO1 as the home switch. When IO1 is activated, it'll then go to the position of when IO1 was activated and set that position to 0 here towards the end of the program. So I'll go ahead and close the program and start building the program from the start. The first command I want to add is a move MRV. So under the Move tab, go ahead and select the MRV command, and I'll give it a large distance. I'll give it 100,000 counts. You want to give it a distance that's long enough or longer than your actual range of travel to guarantee that the motor will travel the entire range if it were to start off at the far end. So I'll give it a distance of 100,000 counts, acceleration of 16,000 counts, and velocity of 8,000 counts. So to command the motor to stop when the sensor is triggered, I want to set a stop condition. So I can do that by selecting the stop button or stop conditions button, and I'll select condition of IO1 either high or low, depending on your the way your home switch is wired. If it's either normally open or normally closed. In this example, I will assume that the motor is home when IO1 is low or false. So I'll go ahead and click OK, and then I'll click OK. You can see it added the MRV command. It's going to move a large distance until IO1 is low or false. Now when IO1 is detected low, what happens is the motor will start to ramp down to a stop, which will then overshoot the position. But what the controller does when IO1 is sensed or triggered, it'll copy the actual position of the motor to register 4. And so the next command after the MRV is to move to that absolute position of register 4, so that we're guaranteed we're at the position when the IO1 was first triggered. So we'll click the Add button, and under the Move tab, we'll select the RAV. And for the data register, we want to look at register 4, which is called the last trigger position. So we want to move to that position. I'll give it the same acceleration as before and same velocity as before, and click OK. So now the next command is to then set our actual position and our target position equal to 0, so we can 0 our home position. So we go under the All tab and add a CTP 0 target and position command. So click OK. So with the 3-line program, it'll start moving 100,000 counts, and it'll stop when IO1 is low false. So once we sense the position or sense the sensor, we'll stop. We'll then move to the absolute position when the sensor was first triggered, and we'll then set the actual position and target position equal to 0. Now, in some situations, the motor on power up will already be in the home switch, or it'll already be on the home switch. So what we want to do is we want to detect if we're currently on the home switch when we power up. We'll want to move away from the home switch before going into this MRV command. So above this MRV command, I'll add an insert. I'll click the insert button, and I'll want to add a flow type command, and I'll add the JOI, jump on input command. On the jump on input command, I'll enter a label, move to home. Okay, and I would want to move to the move to home. So I would want to move to home. I'll double click the JOI and add a condition. Move to home when IO1 is currently high true. When IO1 is high, the home switch is off. We're not activating the home switch. So I want to move to home when we're off the home switch. So this will automatically move to home if we're off the home switch, and then start moving towards the home switch. If we are on the home switch, if IO1 is low, we then want to we'll add a move command to start moving away from the home switch. So I'll add a MRV command, and I'll just give it a negative distance of 8,000 counts. I'll get the same acceleration and velocity, and we would I'll add a stop condition when IO1 is high, which means we're off the sensor. So to give an overview of the program, if we are off the sensor on power up, IO1 will show high, so we want to move to home. It will jump to move to home, which will then start moving towards the home sensor and stop when the sensor is triggered. We will then move towards the absolute position when the sensor was triggered, and set our target and actual position to 0. If on power up we are currently on the sensor, which will show by IO1 being low, this condition, the JOI, is false. So then the next command, the command below, will execute. So then we'll move 8,000 counts. We'll move away from the sensor, and then it'll stop when IO1 is high true. So it'll stop when we're off the sensor, and then it'll run the MRV command. Here we have a Silver Sterling S2X2 IG controller. It's a 2-in-1 controller option. In this demonstration, we're only using one controller. The controller is connected to our iGrade NEMA 23 motor, and it's driving a Lintec belt-driven actuator. The motor starts by moving towards the home switch, stops when the home switch is triggered, then backs up to the exact position when the home switch was triggered. Here's a closer view. For questions or comments, email us at support@quickservercontrols.com and visit our website at quickservercontrols.com for more information.